So, let's go to the principles of UV disinfection. If we're talking about UV light for disinfection, we're always talking about UVC light. So UVA is that what gives you the nice sun tan. UVB is what gave our colleagues from the Nordic European countries this nice red color. And the UVC light is what actually affects the microorganisms we want to target. For UV disinfection, we're normally always talking about UV irradiation at a wavelength of 245 nanometers. The actual optimum to achieve the, I've got a pointer here, to achieve best performance would be at 260, but 254 is just because this is the spectrum from which we get from, what is it? Mercury wafer lamps. So I was missing the English word there, sorry. So what does UV actually do to the particle we want to disinfect? UVC light will penetrate the cell wall, and the photons will alter the structure of the DNA. The microorganism is actually inactivated. It's not directly killed, but it is rendered inactive because it cannot reproduce anymore. So it's by that means it is then it is impossible for the microorganism to infect a human host. This happens mostly through the formation of thymine dimers, which mean if an enzyme comes and wants to reproduce a DNA, it will fail. And it happens not at once, but in several thousand times in the DNA structure. The main target pathogens for UV can be categorized in the three groups. That's bacteria, viruses, and protozoa. One thing that gave UV a nice boost in drinking water is actually protozoa, that's parasites. Most commonly it's Cryptosporidium or Garnia, and the popular boost for UV came through the fact that the typical chlorine disinfection for drinking water is really bad at killing these parasites. So the typical kind of bacteria you're looking at for the UV disinfection would be coliform bacteria, so fecal coliforms, E. coli bacteria, Legionella. We had one case 2 years ago in Germany actually at the Warsteiner brewery. I don't know if anybody knows the beer Warsteiner. They had a Legionella outbreak, and now there's a Wedeco system to prevent that from happening again. We normally look at viruses. It's hepatitis A, polioviruses, or also we should have added here adenoviruses. And the main target group is of course Cryptosporidium gardia. So this is basically the quick introduction to what we actually want to do with UV, and now I want to show you where we actually want to do it. So Wedeco offers in its product range solutions for the drinking water market, both for residential and municipal applications. So our product range ranges from very small units that can handle 1 or 2 cubic meters per hour up to even closed reactor systems that are able to disinfect drinking water qualities of up to 4,500 cubic meters. So we have products for everything in this range. Another key market for us is municipal wastewater. So both the standard disinfection of the effluent for discharge into the sea or into rivers, and also a growing market for us is water reuse applications. So mostly for irrigation. That is a typical application which is done in the Middle East or in the United States, and also parks, golf courses, etc. We can also use UV in a very large array of industrial applications. The most commonly used is for fish farming, which is actually at the bottom of the list. But we also use it for semiconductor industries, pharmaceuticals. Ballast water is the upcoming thing at the moment, so we are closely working together with system builders for ballast water systems. If you look at the typical treatment steps for drinking water, then you will see that UV normally is at the end. So you have your filter, your exudation, softening, pH correction, depending on the quality of your water. If you have borehole water, if you have surface water, these steps might differ, of course. But UV is normally always the last. In Germany, for example, it is mostly the last part. In many other countries, you will have a residual chlorine disinfection after the UV.
Sorry, is that necessary? The chlorination after?
The chlorination after depends on your distribution system. The thing is, with UV is working on the spot. It doesn't build up a residual in the water. So if you have huge storage tanks and if you have a long retention time between the disinfection process and your end customer, then you might have the formation of a biofilm inside your piping or inside your storage systems, and then normally small amounts of chlorine are added to have this long time residual.
Sorry, in South Africa, legislation requires residual chlorine for drinking water application, not for wastewater. So for wastewater, normally it's discharged into a river or ocean, and there is no, requiring articulation of residual. But it's only for drinking water we would by law require.
And for the details to that and the multi-barrier principles, I have some two or three slides in the next section to go a little bit deeper into UV and chlorine as a combination and the advantages of adding UV in your process in the first place. Just as an example as we already earlier today we heard about the application of for building services to supply small package treatment systems, and this is typically for the residential market. We see our smallest UV units being used together with water softeners, carbon filters, and there are some system builders which take our components and provide solutions for households or even for the little bit bigger units, the A units for schools, hotels, etc. So for the A units you have additionally the benefit that you can use it for hot water circles because the lamps are able to withstand temperatures of about 60 degrees.
Sorry,
yeah.
If there's a residual, chlorine's put in for residual disinfection, why do we need the UV? If it's going to kill it.
These solutions are basically normally designed for households that are not connected to the main distribution net. So this is something.
If you go back to the previous slide, you've got UV and then residual disinfection. Why have UV in there if chlorine is going to do that anyway?
What's the rate of consumption though?
So it's just going to reduce the amount of chlorine.
Drastically. It reduces it drastically.
Because I think you are going to talk about that in the presentation. He's going to do a comparison between the UV and the chlorine. Okay. So we'll just touch on that.
And but the main short point is you can reduce your chlorine to 1/10 or even less of the normal amount you would look at. And the benefits of doing that will be shown in three more slides. So yeah, we have the same solution for hot water circuits. For wastewater, UV, yeah.
If you go a bit behind.
Yeah, sure.
Why you don't we don't use the UV then on the cold water line going, and you have to do it after?
We can use it to on the cold water normally too, but this is just an example that that we see in schools sometimes, or indoor swimming pools for their so that because most systems are limited to water temperatures, most UV systems are limited to water temperatures of about 30-35 degrees maybe. And otherwise the performance of the lamp and the lamp life goes down drastically. But we have for these systems lamp types that are capable of resisting 60 degrees and more. For wastewater, we have UV depending on the local laws, basically. You could do it after, if you have just have a primary treatment. In the UK we sometimes see that. That's not even a biological treatment, so you can set a UV system directly after sedimentation and then go to a direct discharge. You can also, in a standard, most of our systems for wastewater are sold into secondary treatment plants, where you have the UV after the clarifier and go then for a discharge. If you put in filtration and go for a tertiary system, then you normally have disinfection with UV. And based on what you want to do with the water afterwards, you might have also advanced oxidation processes, so that might be with combined processes with UV and ozone, or UV and peroxide, or ozone, peroxide, or all three together. So this is something which is important or interesting in Europe when it goes for micropollutants removal, but this is still not everywhere. Even in Europe, we are just in the beginning of introducing these processes on a larger scale. Competing technologies, we already as we already had the issue coming up, what we normally see is that the most commonly used disinfectants are still chlorine, which comes either in the form of free chlorine applied as a gas, or chloramines, or combined chlorine, or chlorine dioxide. We have also the possibility to do disinfection with ozone. We, as a company, Wedeco, are supplying ozone systems too, so we have both in one house, UV light disinfection and ozone disinfection. So it is not that I would say ozone, as we offer both solutions, I would not say ozone is not as good as UV for disinfection, but if you compare both technologies together, ozone is, for a typical disinfection purpose, not cost efficient compared to UV. Typically ozone systems normally 3 to 4 times more from the operating costs, higher from the operating costs because of the high power consumptions. It also, like UV light, doesn't provide a long-term residual. In Germany, in some cities which have a distribution net that has a very short retention time, they use an ozone residual in the pipes to avoid chlorination, but this only works if you have a short or...
When you say short-term, long-term, what timing are you looking at?
It depends, of course, on the dose, on the amount of ozone you put on the water, but for the city of Essen in Germany, it is like they have a residual of about 20 minutes.
20 minutes?
20 minutes. And then it's out of the water. Yeah. But they don't have the issue because the actual distribution net was built for from when there was still big steel industry. So to prevent biofouling in any way, they just they drain the excess water back into the river at the end of the pipe, because the German population and they are not used to chlorine, they wouldn't accept that. So it is cheaper for them to just discharge the water back into the river. Yeah. So yeah. Also, not every disinfection method is equal when it comes to efficiency. Chlorine and chloramine, UV light and ozone all are pretty good to excellent against bacterials. For viruses, chlorine is definitely, next to ozone, the technology that has the most efficient disinfection. I have to admit that, even if I'm a UV person. But really what pushed UV and the main focus is that with chlorine and Giardia and Cryptosporidium, the main protozoa which we are looking for in drinking water supplies, they offer a really poor disinfection performance against these parameters. And the problem is, that means you can do it, but you have to put huge amounts of chlorine in the water to get that, which then would have many bad negative effects. Like chlorine is corrosive. It's very corrosive. It's dangerous to store, and if you want to disinfect with chlorine alone against protozoa, then you are having to dose so much chlorine into the water that you're beginning to form byproducts like trihalogen methanes, haloic acids, and nitrosamines, and all of those are carcinogenic. So this is the thing. The nice thing is, if you are using chlorine just as a residual after UV or ozone disinfection, you are in chlorine levels in the water where you're not forming these byproducts. So it's much healthier to use chlorine as a last step. It also makes your equipment much smaller. The chlorine dosing station or hypochlorite dosing station, whatever you're using, would be much smaller. Would have less, UV disinfection is highly effective against a broad range of pathogens, most notably, as I said, Giardia and Cryptosporidium, but also E. coli bacteria. We do not change the water chemistry with UV light, so we are not forming any disinfection byproducts. It is the disinfection performance of UV light is not dependent on the pH or the temperature of the water. We don't create any odor or any taste in the water. So that is another thing. If it's from a taste odor point of view, the small residual of chlorine you have to if you decide or if you need to put a residual in, you won't have this chlorine taste in your water anymore, because the doses are so low that it's much more neutral to the senses. You don't need to transport, store, or handle dangerous chemicals, and it can be easily installed in existing water treatment facilities, both in drinking water facilities. A UV reactor has a very small footprint normally, and for most and for wastewater systems, we can normally make use of chlorine tanks. So our systems, or open channel systems, are designed to be built into chlorine contact tanks. If the utilities who want to use UV decide for that, you don't need to build a whole new plant for that normally. The one thing that is a nice selling argument is it's cheap. UV is very cheap when it comes to operational costs. The capital costs are also low. compared to an ozone system or to the storage of to build a real chlorine facility, the capital investment cost for a UV system that can do the disinfection is much lower. And our lamps normally last, well not normally, we guarantee that our lamps last 14,000 operating hours, so that's basically 2 years, depending on how long you operate the plant. And all you have to do is change the lamps, nothing else. There's that's an annual maintenance, maybe a check in between, but there's a very, very low maintenance effort you have to do. Most plants we operate in Europe are operated remotely, and there's not even personnel on the site to check on the systems. It's just they come twice a year to replace the lamps or replace wiping systems, etc. Yeah, UV can be effective as a standalone. Oh, sorry.
The UV systems from your company, they have indication that the lamp lifetime, or?
Yes, we monitor with for every system we monitor the lamp life of each lamp separately. So there's a counter showing the operating hours as well as how many times the lamp has been switched on and off. So it's
even for the smaller units.
Even for the smaller units. Yeah. So, yeah, UV system is simple to operate. You can operate them and switch them on and leave them running without having to interfere. And it's, compared to chlorine plants, it is only a minimal risk for the operators because there's no chemicals you have to deal with. So I want to give you first a brief overview about our total portfolio of wet eco systems, and I would like to go from the smallest to the biggest. The smallest one would be the Aquata series. All of those units are designed for low flows of a few cubic meters per hour only, and the cheapest version of that has just a lamp counter. So every bigger system that comes with a control system shows every single lamp. This has just in the cheapest version, it's just an indicator that the lamp has to be replaced. The second cheapest option has a 375-day counter.
So what does it cost?
The Aquata, I would think, well, the biggest one, so that's what 10 cubes an hour.
Yeah, around 10.
More or less, you would look at around between, I think, say 13,000 to 14,000.
That's 10 cubes an hour?
Yeah, 10 cubes an hour, but that would also only be for drinking water, so household applications.
Okay. So that's just, what does that come with?
That comes as the unit with the lamp.
Unit, lamp, and the control box.
What diameter is it?
Diameter?
How does it work?
The diameter?
Yeah, if you just...
The small ones are like this. I can show you...
It starts off at 4 millimeters and goes up to 1 inch, 3 inches.
Okay, just
So
to reach
your bigger unit is a 75 mil frank, and your smaller unit is a 32 mil.
Just 1¼ inch, 1.5.
Yeah.
They start really small. They like that. But the biggest unit they use for like a lodge or something will be, it's 2 flanges with about this size.
Okay.
Yeah, from the Aquata series, the next bigger one would be the A series, which goes a little bit higher in flow, but it's still one of our smaller systems. We would then go on to the Spectron series, which is from the application point aimed to small drinking water plants, municipalities, up to the biggest units in the Spectron series. The new Spectron 4000 is able to treat flows up to 4,500 cubes.
Per hour?
Yeah, per hour.
And how free of like mud and sand. So how, must that be completely clean water?
It should be, if it's for drinking water, yes.
Potable water only?
It's potable water only. The closed reactor systems we have are potable water only.
You have to do filtration before you do UV, because UV is about the penetration of the wavelength into the whole the water stream. So if you've got turbidity in the water, the wavelength doesn't ever penetrate the patterns. So it will not do its work.
Yep.
So you have to do nano and macro filtration before you go to the UV.
At least sand filtration is necessary. Yeah. So typically we have sand filtration in front of for drinking water.
Householding, if you take it from a water bowl or from a water source like a dam close to your house, you put it through a cartridge filter. With a probably 50 micron filter or something. And then you just put it through the upper dock and it's drink water. It's better than the wet stuff that you probably get out of the tap. Just keep in mind that it always needs to be filtered.
Yeah, I just wanted to mention that the two things that we do measure for the UV is suspended solids, so that should give you an indication, and then your UVT.
Yeah.
I don't know if you've got a picture of what
UVT is basically, I mean, most of you are familiar with turbidity. UVT is basically turbidity but measured at the UV light at the 254 nanometers, because turbidity is not directly linked to the actual transmittance of the water. I have seen a water sample that was as clear as the water in this bottle and had a UVT of 30% due to the chemical compounds in the water. So you cannot see UVT really. Mostly you do. In most cases the water is brown or yellowish. You can have an idea, but I also saw crystal clear water samples which had a very, very low UVT. So
just to clarify on the UVT, that's just the absorbance of UV light that goes through, or that is being transmitted, UV and UVT. So if it's 80%, the higher your UVT, the better the quality of the water. So
it's normally measured at UVT measured in 1 centimeters. So if it's an 80% UVT, then if you put 100 watts inside the water of UVC output, then after 1 centimeter you still have 80 watts. But after 2 centimeters you only have 80% of 80 watts. So if you're talking about wastewater, then you would talk about for primary treatment something between 15 and maybe 30% UVT. We have sites in the UK where we do stormwater disinfection, where we have UVTs of 17%. So after 1 centimeter from 100 watts, there's only 17 watts left, and after another 1 centimeter, basically nothing. So secondary treated wastewater, you're talking about between 45 and 55% UVT normally, and for tertiary, depending on your pre-treatment step, you're talking something between 60 and up to 75. If you have a good filtration, you can get a very high UVTs after tertiary treatment, and the higher the UVT, the better for UV. So the smaller your system. Because of this, a drop of 5% UVT can, in some ranges, double your UV system you need. So UVT is the key parameter next to suspended solids for the system design. So if you're coming to a customer who is interested in UV, that is the most important question you should ask, is the UVT. If they have measured it, and if yes, how high is the UVT? That's the main.
In my part of the world, I don't think anyone knows what an instrument looks like.
No, but nobody measures it in South Africa.
UVT measurement. So can we buy that tool?
You can buy.
Yeah.
We've got an in-house one as well that we can use. You can buy the tool. I think it was like what, 60,000, 70,000 there. Not a lot of people. Not a lot of people do use it at the moment, but there are certain assumptions that we also make. I mean, we know more or less the range potential is 80% more or less. For wastewater, we work on about what, 60%?
55 to 60,
It can just start to give you like a budget price, selected units, So you don't necessarily have to measure it before we can give you a budget quote.
Yeah.
So for final selection, it's better for for budget purposes, you don't need to use theory, but final selection is good to measure it.
The further away you go from reliable water sources, the more you need to be sure.
Yeah. So it depends also on the project. I mean, with a small household unit, you're more or less certain, what the water quality should be like, more or less. And if it's a bigger project, municipal, so yes, we can measure it.
What's the difference between turbidity and humidity?
So
turbidity.
measured with what, visible light?
Turbidity is measured for visible light.
Yeah, the turbidity is mostly organic material, where you measures the chemical as well. There's chemicals in the water that is not visible, but it affects the UV going through the water.
Yeah.
So turbidity is basically biological gas. So it's sand and ooze and stuff. But this measures that, and it measures the chemical compound in the water.
Yeah.
Is that something like iron?
Yeah.
In your water?
Yeah, you won't see it.
You can't see it visibly, but it's going to cause a block to be
Well, anything else.
Yeah.
Natrium, natrium, all those things.
Aluminium. Yeah.
You won't see it, but it's there and it can affect UV effectiveness.
Well, I'll tell you, most of our plants, okay, now here, I know a lot of plants in South Africa, we have a lot of iron. So you're going to have a lot of UVT. Because what we do is we pre-treat with chlorination to get rid of the iron, but we still get off your filters. I mean, we encountered it something in magnesium and stuff like that.
You rather than use ozone. Ozone is better.
Because with ozone you do oxidation, so you actually get rid of the metals and everything out of it. So you'll probably do some kind of ozone building and then through UV again. So you can't do it's a final polishing stage.
Yeah.
The main thing here is just one question.
Yeah.
Does water need to be tested at site or can it be tested off-site?
It can be taken off-site. You can send us
So if I take a water sample and I send it,
to Hereford. You can send it directly to Hereford.
yeah, well, we've got a testing unit, so if you send the water to us, we can do a test and we send you the results. So you don't have to buy this.
So that doesn't, the water, let's say we're carrying it in the sun, it doesn't affect the
No.
sample.
No.
Not the UVT. It's not for
Not for the UVT.
Shouldn't it?
No. You can store it.
How to have a few samples, maybe one, if possible, if you work on a very big project over a long duration. Have one in summer, have one in winter. If you're working at waste so different times of the day where different things are happening. It's useful to have that to have range.
If it's single use, 1 or 2 samples will suffice.
Yeah.
If it is a big project, you need to have a week or 2 weeks data and possibly multi-seasonal.
Yeah. If it's
If you're going to do a 2 megalitre plant, you want to base this on at least a year's data, water data, before you commit to any process guarantees. But if you're testing to do out of this reservoir here, you want to test here and this UV it for disinfection before it goes to your taps here, then 1 or 2 samples will be more than enough. As long as it measures within the upper part of the measurement.
yeah.
So we got a situation, our dams are practically empty. So they're taking bottom of the dam level water. And they're working with that. And so it'd be interesting to how clean, like you said, it needs to be filtered before you can actually use it.
It's the best to
And then ozone gets around the light penetration by penetrating the entire water.
Now, UV is not, ozone is actually ozone. It's a type of gas.
So the one is, your UV is physical disinfection, so you use a light to disinfect, and your ozone is similar to chlorine in the sense that it oxidizes.
Yeah.
So it's very different.
Chemical reaction.
So it just oxidizes better.
But what you can use, what I just want to mention, is suspended solids and UVT and all those things. It's just, our systems can handle up to a UVT of about 30%.
Yeah.
And even suspended solids up to what, 30 or 50 milligrams?
Depending on what you are looking at it for wastewater, it depends on your effluent quality you have to achieve, because suspended. Yeah.
So it's just going to be more expensive. You're going to have to use a bigger unit. So it could be, it's going to be more cost effective to have a better quality water prior to UV. So if you can't do that, we can still treat it. It's going to be a much bigger, expensive system.
It's like a tanning salon. The longer you're in the tanning salon, the browner you get. Now you want exactly that. It's not exposure. No, so if you're, what is it, UV, what is it? UV2.
Yeah.
If UV2 is low, then you need a longer unit because your contact period needs to be longer.
Not very close in the tanning salon, basically.
Yes.
UV2 is low. Well, and that's actually more your suspended solids.
Yeah.
Our suspended solids are very close in the
Yeah, and then your chemicals would be like tanning solution. And if you still want to tan, you need to increase your length of exposure. Yeah. So what happens, you physically get a longer unit and you have the water running for a longer period of time under the UV. The cleaner the water, the shorter the contact period.
And then there's...
If you've got longer contact period, you're using more energy.
It is
cheaper ways to just sort out the upstream issues so that you can...
Very simple. Filtration. The best filtration you can afford, and that comes through that filtration you will take care of. That's the
So it's basically, you have to look at the process and then decide, okay, I can do it with a really large UV system that would cost this much, but if I increase the filtration quality to a better filter or a bigger filter, I just need a fraction of the size for the UV system to ensure the actual disinfection. So there's always this you have to do this exercise for big plants to see what is a cheaper option for you, what is a better option. We can of course treat low UVT water, but that system size would go up. So sometimes it's cheaper to just think about the filtration step beforehand and go there. It's always, as with all process steps in a wastewater plant, you have to take into consideration what do I take this step a little bit bigger and can have a smaller step afterwards, or you have to balance that out.
Matthias, come back to the question that you had regarding the iron in the water. Is there a way, besides ozone treatment, to combine it prior to UV disinfection? Would they precipitate it out of the water beforehand and then use UV, or would you recommend ozone as the better option?
It depends on how much iron you have, because with iron up to I have to think, I think I can look up the number, I don't have it in this presentation sadly, but up to a certain amount of iron, it's the only effect you have with iron is an increased fouling potential on your quartz sleeves, but that is something which the wiping system can take care of. So it's normally, you have to look at a case-by-case basis how high your iron concentration is. But we have a lot of iron dosing in the UK, and so we are aware of this, and we have solutions for taking care of high iron contents in the water and still maintain our performance.
So could they be either UV or ozone, depending on the concentration?
It depends on the concentration, as we already basically spoke about the Aquata series and which applications, homes, schools, farms, hospitals, hotels, etc. And we can also use it for fish farming, and this is just, as I thought, they start in this size and go up to this size. We have the same, a little bit bigger, would be the A series for a little bit of higher flows, so up to 26 cubic meters per hour. And both systems are designed for UVTs of minimum 80%, but yeah, this is a typically you want your drinking water with a UVT of 90% or higher. That is what you typically see. We have some cases where it's lower than 80%, but there you would need a bigger solution then. I just want for drinking water, the last system I want to go into before I will talk about our wastewater pilot container is the Spectrum series. This is aimed at more municipal markets or process water industry and food and beverage industry. It's the Spectrum series, which all the smaller systems are single lamp systems. The Spectrum system starts with single lamp systems and goes up to 24 lamps per reactor. And this is just a typical setup. You have a flow enters through the vessel here. You have the lamp arrangement. You have typically we have always calibrated UV sensor to measure the UV intensity, and we actually use the UV intensity to calculate the dose. So some of our competitors just calculate the dose based on a fixed lamp aging formula and the power input, but we actually, as a safeguard, check the actual light that reaches the sensor. So some other competitors don't do that, so the system syncs. It is because the power consumption is at this level, and the lamp is this many hours old, so they know, okay, it should have this dose. But then the wiping system fails, the sleeve is fouled, and nobody knows it because the system doesn't check the intensity. Vertical systems do always calculate the dose based on the actual intensity. So if there's a problem with your UV system, you will know it. Just to show you a range, the smallest Spectrum, this is a lot of information, it's just included this because I want to show you the range that we have systems from 2.9 cubic meters up to a design of over 4,500 with different lamp types and different numbers of lamps to suit every possible scenario you could have when you're looking at portable water supplies. Also, the Spectrum series is certified and validated according to international standards like the DVGW or ONORM. I don't know if you are familiar with these things.
It's not a requirement in South Africa, but maybe you can just explain the benefits of having a validated system, because a lot of people are wary of trying out new technology, etc.
I mean, you can dose calculation can be a little bit tricky, and it would take A, too much time, and B, go a little bit too much into detail. But there are certain in Germany and Austria, there's this DVGW and ÖNORM certified systems. They are tested with target pathogens to achieve a certain log reduction of those microorganisms, and it's not pathogens, it's microorganisms that are harmless, but those can be then compared to pathogens you have in your water, and you know, okay, the system was tested for a flow of up to 60 cubic meters, and it achieves this performance for a reduction of these target surrogates. Then we know that in a real world application it will be sufficient for a 3-log reduction of cryptosporidium, for example. The US EPA for DVGW and ÖNORM just do it with one very hard to kill target organism. The UVDGM actually looks at different target organisms. So those are the ÖNORM certified and DVGW certified systems are designed as a broad spectrum disinfection system, so it gives a high security against a lot of pathogens, while UVDGM validated systems, the UVDGM validation is based on a test report by a third party. The other ones are by an authority, done by a certificate issued by a German or Austrian authority. UVDGM is done by a third party, and with these reports you can then select a system and design it target specific to one special pathogen. If you know, okay, I've got a Legionella problem, then you can design your UV system to fit directly this application, to design it specifically for Legionella, 2-log, 3-log Legionella reduction, for example.
So it acts as more of a process guarantee?
Yes. So because the other methods are just calculating the dose from a theoretical base, and there you have a lot of simplifications, like you don't consider the flow pattern inside the reactor, etc. But as these are based on actual biological tests, you know the real performance of your unit with these, and gives you a much better overview of what your system can actually do. It gives you a lot of safety, and it gives you a lot of confidence that you can say, okay, I know this system, as it has been tested with these and these parameters, will definitely bring this performance, and I need this system. I don't need to oversize the system to have security because I'm not sure what my system can actually do. Which is the case if you don't have a bioassay, then you're just basically guessing, because 30 millijoules for example, is just as an arbitrary number on a UVT of 50%, calculated with standard theoretical approach, is something completely different at 30 millijoules at a different UVT. So you don't know what your performance is, and with these certified and validated systems, they are tested over a huge range of points, and you know actually what you can really do with your system.
Yeah. So if I look at the ones 80, 25, the first one on the left, I see there's not many options. I mean, it's just one lab, maybe one flange, and not too many options.
Yes.
It's a product that will typically go to market through like a WhatsApp channel. It's a product which you take to market through a WhatsApp channel where you just put in boxes and you sell, not much.
Those systems are, there's not much of, but we have them certified for DVGW, and what typically is, these you can directly select out of a flow table. You have a flow table that shows, okay, up to this flow at this UVT, the system is DVGW certified, so it makes selling, especially the small units, very easy. So you don't need really a system designer if you have the UVT, and if you know, okay, I want broad spectrum disinfection, then you can select them directly out of a flowchart. It's a little bit like a working field for a pump, but yeah, so it's for the bigger ones where you have the UVDGM validation, you can do those units and have them selected target specific, but for the DVGW or ÖNORM systems, even the bigger ones can be selected out of a flow chart, a flow table. And just a comparison for the Spectrum 2000, just to show you some. We use here 600 watt lamps compared to the 300 watts in other systems, and we made a comparison in one project which we actually won, where we were bidding against the Trojan D30. The D30 has 30 lamps, the Spectrum 2000 has only 12 lamps, and at the same exactly the same connected power, so same output you get out of that. We used only 40% of the lamps. So, and we were talking here about 8 systems in parallel, which were for a project in Singapore. So 8 times 12 is something else than 8 times 30, so you can save a lot of money with these bigger systems if it comes to maintenance and operational costs.
So Trojan is just a competitive product?
Yeah. It's a main competitor.
Yeah, main competitor. That makes
What's their presence in South Africa?
They actually, in South Africa, they have distributors that deal with it, but they don't have an actual base like Xylem has got. But they have got a few installations in Cape Town. But we're actually meeting with the City of Cape Town this week to discuss that, because they're not happy with the aftermarket support and stuff that they're getting from Trojan in the country. So yes, they've got references, but it's old systems, and there's a scope for Xylem products as a replacement of those.
And yeah, as we are talking with that about wastewater systems, another step to push UV in wastewater here is we just provided, or we are in the way of providing, it should be on the ship soon. We have a 40-foot container system which comes with a containerized plug-and-play UV system for, it's an open channel system for wastewater disinfection. It's a 40-foot container transported by truck and ship. It has our latest lamp technology inside. We also have the possibility to switch the center line of the lamps. So we have standardized, it's the M center line, that's 120 millimeters between the two lamps. The S center line has 110, so for low UVTs, etc. We move the lamps a little bit closer together and get a little bit higher UV dose out of it. But it just has a exchangeable module so that you can test both applications. Power supply is TNS, earthing system 3PM. And it also comes together with a submergible fluid pump already, so it's explosion-proof version of the 3127. And as a flange connection for the inlet DN100 and outlet DN150. Just want to show you a few pictures of how it looks like. Stainless steel channel inside with 3 banks in a row. Each bank has 1 module with 2 lamps deep and 2 next to each other. So it's 4 lamps per module. We have 3 banks, so we can have multi-bank system, and which is better for the actual performance, because it is you create turbulence after the first bank to get a better mixing. So if we want, for example, like here in some cases we are looking at very low disinfection targets, like non-detectable, there you want a second bank just to ensure the mixing. And yeah, this is one system which we are very proud to have, which we are now proudly delivering to the...
Where's it going? What's one we can brand first?
Whoever first come first serve.
So it's coming to
as a trial unit. So
it's coming plug and play. You take a customer plant,
yes.
You test it. It's like a rental unit.
Okay.
For trials or pilots.
It's proving.
Let's prove the concept.
Yeah.
Because people still don't trust it.
Yeah.
They don't know.
So you can just put it
our distributors don't trust it.
Yeah. You can just put it next to the existing treatment line and take a side stream to make proof of concept and run some tests, biological tests, and convince the customer that the system actually works, because it's, as I was informed, at least by my South African colleagues, it's kind of new. So it's not so popular as a treatment method here at the moment. So.
We mainly dominate. It's not but it's not very effective.
I already overstepped my time, I'm afraid. I have what? I have minute? I have how many?
You're over by 1 minute.
Oh, that's good. But still, if it's okay, I would at least 5 minutes if you have any more questions from your side. I will, of course.
Do you do the filters as well? Because, you know, we as distributors, we have to supply systems, not just we need products. We do EVR, membrane filters we do in America. It's one of the brands that we're looking at actually bringing to South Africa as part of a total solution. What we picked up is that in Africa, the water quality, people don't want to UV the stuff that's coming out of the tap. People want to UV the stuff that's coming out of the dam, the river, or the channel, or wherever they get the water from. And with the water scarcity that we have in South Africa now, it's becoming reused water. It might not be directly from a treatment plant or anything, but it's mixed and all of it. Yeah. So disinfection starts playing a bigger and bigger role. But disinfection only works if it's being filtered. So we picked that up. So there's two things. One is on large scale would be membranes, and then secondary would be a smaller scale where we want to get a tie-up with a local supplier of normal cartridge filters, where you for 5 cubes an hour or 3 for cartridge filters that we can locally get at a very competitive price. Sign an OEM agreement with those guys and package it together with our Aquadam. Yeah.
So we are going to incorporate it from our point of view. Otherwise, we're once again selling just a part of the solution. I mean, you're not successful with that. We want to go to the guy and say, we can test your water, we can give you the filtration, we can give you the disinfection. When it comes out there, you can drink it.
Yeah.
Otherwise, once again, I leave it up to you guys to now source a filter here and a pipe there and a valve here and once again be able to have, let's call it standardized plug and play combined solutions that be a little bit adjustable. You know, you can put these filters with that UV system and the other way around. There is some filtration that you can use for iron as well, but it becomes expensive because iron blocks filters. Doesn't matter how you look at it. Because you need to use ceramic cartridge filters. So if iron goes through there, it's blocked. So it's a regular maintenance on the cartridge filters.
Yeah.
But there are different solutions to different applications.
Yeah.
Specifically, if you go to certain parts of South Africa, probably Africa as well, the iron content and salt content in your boiled water is to such a point that you can't use it.
For a standard low pressure UV system, you will get a little bit of reduction of your residual. So, but that depends on how much chlorine is in the water.
And if they block that, if they don't block that UV range, but because you're actually blocking the lower UV output.
For
the low pressure. So you're blocking those to prevent dangerous byproducts from forming.
Yeah, that is low pressure is just. You prefer medium pressure?
Sorry?
You prefer, sorry, I didn't understand.
No, mix the
medium pressure is polychromatic light, and there you have the problem that you're putting a lot of power in the water, because the normal low pressure lamp we're talking about for our bigger systems even UVC output per lamp of 150 or maximum 210 watts output. For a medium pressure system, you have lamps that have a lot more mercury inside, and B, operate at a higher temperature. And there you get not only the spectral light emission from the mercury, but also from all the other stuff that's inside the lamp. So you get not only 98% peak at 254 nanometers, but also a huge range of all the UV broadband light. And that can cause the formation of byproducts with chlorine in medium pressure.
UV lights combined with chlorine can create byproduct?
Medium pressure.
Not with our lamps.
Not with our lamps.
Not with our lamps.
For our normal, even for our medium pressure systems, we would then just put another quartz sleeve in, which blocks these frequencies that could cause the byproduct. So for these solutions I presented you today here, it's absolutely safe. It is the only thing is it can destroy a little bit of chlorine, so your residual might be slightly low. Yeah.
It doesn't remove the chlorine.
No. You would need a very, very, very high UV dose. So you could also boil the water basically. If you have a standard chlorine inside, you will not reduce it that much.
Well, that's a good question. It doesn't increase the temperature of the water.
Medium pressure lamps can do that.
And we're talking low.
We need low pressure.
And low pressure is up to what pressure?
Pressure
0.1 bar. So the temperature of the lamp, the surface temperature of the lamp, not of the quartz sleeve around it, is around 100 degrees Celsius.
Okay.
So for all our low pressure systems, you can have zero flow conditions for over 30 minutes without overheating the system.
So it can stand for 30 minutes?
30 minutes in standing water with lamps running at 100% power without overheating.
Okay.
Medium pressure is what? 800 degrees?
600 to 900 degrees.
Do you have systems that automatically switch themselves off?
Yes.
You have a no-flow on valve.
Yeah, like you do UV disinfection in a home.
We have...
There's some water that we use for a couple of hours. You don't want problems.
No, maximum range, you get a solenoid valve.
Switch it on.
Yeah.
If something happens to the lamp or whatever.
You should switch the lamp and then off automatically.
Yeah. We have over temperature switches. It's just basically a bimetallic plate.
But that doesn't come standard. That's observation.
Isn't that like part of all the UV?
For the Spectrum series and upwards, definitely it's standard. You can get a full temperature.
I'm talking the little ones.
The little ones, the quarter.
The household.
They should.
Household.
Yeah. Household. Okay.
The upper does come with a control box. And that control box doesn't put the light on unless there's flow through the upper. You have to have flow before the UV starts. Because you have to have movement over your lamp.
Once it stops, when it's on,
as soon as you close your taps and there's no flow over your upper dial, it switches off the lamp.
Yeah.
Because you don't want to use energy. You don't want to burn a lamp if you don't have to. So it's actually flow triggered. So when you open your taps and it starts flowing, it comes down. When it stops, it stops. There might be a delay, I think, and I'm not 100% sure.
Yeah.
They're designed to plug in and almost forget about it.
Yeah.
They operate.
In our part of the world, that's how you want it. You don't want any intelligence required.
This is the main thing, guys. If we look at chlorine is a very manual application. You have to order your chlorine on a monthly basis and all of that. If you can get the guys to change over to UV, the downfall on this is that, like Lucinda said, is that there is a residual chlorine that needs to be done. And the only reason that is because we do upstream disinfection. We disinfect it at the treatment works.
Yeah.
Anything downstream is open for dare I say, reinfection? Reinfection is the right term. So what happens is it gets disinfected with chlorine or with UV at the treatment plant, but now it's pumped up to a reservoir. Now that reservoir, doesn't matter how you see it, there is outside contaminants that comes in there. Now that residual chlorine helps to keep that disinfected. But it goes down from kilograms of chlorine per hour down to grams per chlorine per hour if you do UV in front. Yep. So the biggest saving is operator input, because you're going from a huge UV chlorine dosing system to a little dosing pump with a bit of grams every hour. And you buy a lot less chlorine every month, so your chemical bill comes down. And UV is kind of self-operating. You have, once in 3 years, you have, when you change the lamps, that's the benefits that you need to sell to your customer. And we do understand it's a difficult concept. Guys Well, I see the chlorine in the water, not really. UV you can't see. It comes in on this side and goes out on that side, and now you tell it's clean. So that's why Xylem has pushed for the UV plant unit. So you get a customer that wants to save on his chlorine bill, and we will prove it for him within 2 to 3 months that he can save, and we're talking a lot of money. Chlorine bills for municipalities on treatment. I think that, except for electricity, that's the highest cost of the
If they disinfect.
Well, let's generalize.
Yeah.
They should disinfect, so that should be the second highest, except for anything.
You want this?
Yes. So, I think this gives me an impression that we might get some things which are comparable.
Oh, sorry, I'm just coming a little bit in front. So.
I'm saying, for me, it appears like there are some units that are comparable. Where you can have a customer who would say, either I want to buy UV or ozone. And at some stage, you talked about ozone being more expensive than UV.
Yeah.
But if you take into account the operating costs, changes of lamps and the like, will it still come out cheaper over time?
Much cheaper. Still much cheaper. I mean, I'm very interested in selling ozone too. It's not my direct department, but we have very good ozone solutions at Wedeco. But the energy cost, we're talking about, for the same application, we will be talking about maybe a few kilowatts for a UV system, and or a few hundred watts for a UV system, maybe 1.5 kilowatts, something like that. And to get the same effect from a disinfection point, we are talking about 25, 30, 40 kilowatts
probably
for ozone.
40, roughly estimated. You need to remember, when you're doing UV, you're generating the light wave. When you're doing ozone, you're actually taking oxygen, because you still have a gas that comes in. You have to have oxygen, or you have to have if you don't get pure oxygen and put it into your ozone unit, you have to have an oxygen generator which uses power to do that. Then it goes into the ozone, which splits the molecule and creates ozone. That uses energy. It's extremely well, like you said, it's excellent, but it's in certain cases where you need to do more than just disinfect, I would say. You won't use, and this is my opinion, but you won't use ozone to disinfect. You'll use UV to disinfect, and the next step, if you need to do more than disinfect, then you go to ozone, when there's chemicals in your water. You know, if you've got a high cyanide level or anything like iron, manganese, these guys are better than I do. But so when we test the water, and it's standard water, it's within all the limits and all of that, all you need to do is disinfect. UV is your, by far, maintenance-wise, the cheapest solution.
So once you get there, then you now compare it with the product. Then that's where you talk about the number of reps and stuff.
But then also, you know, we've got a lot of advantages. You know, we limit our wavelength, that we don't create unnecessary, what do you call them? DHAs. So we've got advantages if you go very technical, but it's very simple. We do UV just better than the rest of them. We've got a better technology on our lamps, so we've got longer lasting lamps, we're using less energy, and we're getting better disinfection. That's what it comes down to. Then you can add into the technical stuff, like we limit our wavelengths, that you don't create the byproducts. That's the easier word, thank you. But you only get to that discussions when you really get there. The simple idea is to start with one project in your area where you want to do disinfection. If we look at building services, there's a lot, because a lot of the buildings store water and then it's reused. And water that is stored normally, you know, specifically in the heat like Cape Town, it starts, you know, growing whatever gets through the system. So if you put a little UV system on there, it just disinfects that again, and you've got clean water again. So there's a lot of opportunities. Guys that farm with koi, You know, if you've got a cartridge filter, you've got a UV system, you can actually almost drink the water that the koi is swimming in. That's how clean UV can get it. You will not get sick of it. As long as you filter out the koi poo and then I'm not advised for drinking koi poo, but as long as you filter it out, it's through a filter and it's through UV. Swimming pools, you know, I live up in Pretoria. Swimming pool, every time the weather goes up, you know, swimming pool goes green. If you put in cartridge filter, you put a UV system in it. You don't get that because there's no algae organisms that actually can grow. Where with disinfection, you've got chlorine that interacts the whole time with that. UV prevents them from actually existing.
Also, if you guys don't know what questions to ask the customers, because that's normally the thing, you feel uncomfortable, promoting the thing, we've got a standard questionnaire that we use. You can just use as a guideline when you have discussions with the people. You know, you sound like you know what you're doing, you just ask the right questions, and then you bring that to us, and then we can guide you through the process, like Benny said.
I'll do one better for the Sinna. We'll get the Sinna, Helene and Gerard to come to you guys.
Yeah,
Spend a bit of time with you guys talking about more, because we can't do this in an hour or 2 hours. Treatment is 2 weeks discussion. But what needs to happen is that you need to understand that we've identified this as a very good opportunity wherever you guys are. So the next step would be is actually for Lilian or Gerard and we've got Brendan not really on our team, but he's available, should be, but he's not on our side.
Well, he can.
You know, we can get, I see Matthias actually likes South Africa, so we can get him back if it really is required. But I think through the local team, we can start generating the interest. But we'll have to do it at your customer, and that's what we will commit to.
One thing that you mentioned is rainwater harvesting. I mean, people are looking at alternative ways, obviously, of treating water. So that's also another application that does come up.
We have to take the metals into account, but we have a conversation.
UVC falls in the invisible range. Why do you see a blue light when you switch it on?
We have the light we emit is 98% or around 97-98% UV light at the wavelengths of 254 nanometers, but there is also a little bit of gas, stabilizing gas, etc. inside the lamp. So and that is the same principle like we have it in a fluorescent neon light. So that is why we see a blue light.
The easy answer would be it looks cool.
It looks damn cool, yeah. Thank you for your time. Yeah, so if you have any more technical or special questions, etc., because it's hard to put it in 1 hour.
Sure.
And so I tried to give you a short overview, but yeah.
Thank you.
Thank you for your time.